Okay, this is another exam type question. So we have the circuit in figure 1 sorry, shows how an LDR can be used to turn on a circuit when it gets dark. Okay, so LDR, remember, when the light intensity increases, the resistance decreases. Know this, okay? The light intensity decreases, the resistance, that's the LDR. Okay. And then it says, so we got a 9-volt battery over here. We got a fixed resistor, which is 1000 ohms, and we got this LDR. It says if the light intensity decreases, what happens to the current and the potential difference across the LDR? So if the light intensity decreases, so we're basically talking about this over here, that resistance will increase. Okay, so if we use the equation over here, V equals IR. So now in this case, if we have the R increases, what's going to happen with the potential difference is actually going to increase as well. Okay, so we could say voltage increases. Okay, that's number one. Number two is if the resistance increases and we make I the subject. So in this case, we got I is equal to V over increase in R. So we can automatically see when the denominator gets bigger, that means the overall answer will get smaller. So the current has to decrease. So using the equation, we can say the voltage increases and the current decreases. Okay. Okay, next question. It says B over here. When the potential difference across the LDR is 3 volts, what is the resistance? Explain your answer. Okay, so now all we're given is that the LDR is 3 volts. Okay, and so we know that in a series circuit, we know the total, so VT equals to V1 plus V2. Okay, so if this is a V1, we can say this is going to be V2. All right. So if the total voltage is 9, we know that V1 is 3, and we know that V2 then has to be 6. So V2 has to be 6 volts. We know that the voltage is 6 volts over here. Okay. Now it's the question then asks the resistance. Okay, so first, before we find the resistance, we need to know the equation, what equation we're going to use. So we're going to use V, we need to use R, and we need to also use current, because we can find current using this. We're going to still use V equals IR. Okay, so we know what the V is. We know we don't know what the current is, so that's what we're finding out now. So remember, the current is the same across anywhere in the circuit. So the same current here, the same current here, the same current here across anywhere in the circuit series. So series circuit, sorry. So over here we got the resistance, and we got the potential difference. V equals IR. Using the equation, we can find out what I is. Following, we have here, so V is 6, R is going to be 1000. So we can say that the answer for this one is going to be, for current, is the following. It's going to be 6 over 1000. And we know the volts over here is 3. So now we can find the resistance using this, okay? So we rearrange the equation. We can use V over R, or V over I. It gives us the resistance. So now we know it's 3 over 6 over 1000. Now we can use a calculator. We can just do it manually. We just multiply the bottom number by the top when you have a reciprocal of a fraction. So we're going to get the following, which is 3000 divided by 6. And so the answer is going to be 500 ohms for B. All right, question number C. It says, when the light gets dimmer, the resistance of the LDR becomes 1000. Okay, so in this situation over here, let me just rub all of this out. So in this scenario over here, we know that the LDR becomes 1000. Okay, So we can say, oh, at this point over here, the resistance is 1,000. So we've done this, okay? Calculate the current through the LDR when the resistance is 1,000. Okay, so we know that the total, so the total T, sorry, so we know the RT equals to R1 plus R2. If this is R1, this has to be R2. Okay, so the total resistance has to be equal to 1,000 ohms plus 1,000 ohms plus 1,000, 1,000. So the RT would be equal to 2,000 ohms. Now, once we have that, we need to calculate the current. Because we got the total voltage, we got V equals IR, and we know that the resistance is 2,000. We know the voltage is 9, so we can do V over R gives us I, and so the answer is going to be 9 over 2,000, and we can use the calculator to sort of work this out. So it's going to be 9 over 2,000, and so the answer should be 4.5 times 10 to the power minus 3. Okay, 4.5 times 10 to the power minus 3.